Welcome everyone. In this video, we'll find absolute maximum and minimum values of a function of two variables in a closed domain. So for this problem, we'll consider this function right here in this domain. So as you can see, this is a disk, including the boundary. So this will be the circle of radius 1. Okay, so let me show you the steps before we dive into the problem. That way you know what to do first, second, third, and so on. So these are the steps I usually like to recall. This is taken from the textbook again. To find the absolute maximum and absolute minimum values of a continuous function f on a closed bounded domain, first thing you want to do is find the critical point of that function in that domain. Second, you want to do is find the extreme values of f on the boundary of the domain. And then the last step is to compare the values. So the largest value will be the absolute maximum in that domain, and the smallest will be the absolute minimum. Okay, so let's get right into it. So we will first find the critical points of f. So we need to take the partial derivatives with respect to x and y, set them equal to 0. Now before that, I do want to draw my domain. That way we have that in here. So let's suppose this is our xy plane. X squared plus y squared less than or equal to 1. So that's just this disk right here of radius 1. Try to make it straight. Here you go. So we're looking at this interior of this disk. So let me just maybe try to shade in this way. So this is the region we are interested in, finding the absolute max and absolute min of this function in this region D. Okay, so first we're going to find any critical points of f in this domain. So let's do that. So find partial of f respect to x, partial of f respect to y. I'll take the partial derivative of this respect to x. That will give us 6x squared. Then we set it to 0. That'll give us x equals 0. Then we take the partial derivative of f again respect to y now, before y cubed. Then we set it to 0. That gives us y equals 0. All right, so our critical point of the function is 0, 0, which is the origin right here. That's in the region. So we can compare the function values. And step number 3, let's go ahead and find the f at 0, 0. So then we can hold on to that. So I plug this into the original. I will have 2 times 0 cubed plus 0 to the 4th. We know that's going to be 0. So let's hold on to that. This is one of our function values that we're going to compare in step number 3. All right, the next step we're going to do is find any extreme values along the boundary of this domain. So the boundaries consist of a circle of radius 1. So we're going to use the parametrization of that to represent the boundary of this region. So step number 2, our boundary is going to be called C. That is going to be a circle. So I'm going to parameterize it. This is going to be x is equal to r cosine of t and y is equal to r sine of t, since it's centered at 0, 0. Now, since r is 1, we know this distance is 1. So our parametrization to represent the boundary would be x equals to simply cosine of t, y is equal to sine of t, since r is 1. Now, you want to plug these into your original function and put it right here. Now we're going to represent this in terms of a function of t. So the boundary will be represented as a function of t. So x is cosine of t, y is sine of t. I'm going to substitute them into my original. That'll be 2 times cosine of t cubed. So it'll be 2 cosine of cubed t plus sine to the 4th t. All right, so I replaced them into my original. Now we need to find the extreme value of this function. So we'll take the derivative of this function respect to t. That's a single variable. So we know how to do that from single variable calculus. Use the chain rule right here. So we'll have 3 times 2 times cosine square of t times the derivative of cosine. That will be negative sine of t plus 4 sine cubed t times cosine of t. All right, and then we're going to set it to 0 to see if there's any critical numbers that we can use along the boundary. So this will simplify to -6 cosine square of t sine of t plus 4 sine cube of t cosine of t. Then we're going to set it to 0. So let me do a little factoring. So I could pull out a negative. I could just pull out a 2 cosine t sine t. Then we will have the first term will be -3 cosine of t, and the next term will be +2 sine square of t equals to 0. All right, so we have these two equations to find the critical numbers. We'll set the first one to 0, cosine of t times sine of t times 2 equals to 0. We'll get a critical number from here. Then the next one, we have -3 cosine of t plus 2 sine square of t equals to 0. The first one, if we solve it, you can divide by 2 to get rid of the 2. You can take cosine of t, set it to 0, and then you have sine of t equals to 0. Well, when is cosine equals to 0? But we know cosine is equal to 0 when t is equal to pi over 2 and 3 pi over 2. So those are our boundary points. If you can go, let's see if we go back. So that's this one right here and this one right here. So we'll have to work on those. We'll have to determine what is the function value at those boundary points. And then now, of course, any 2k pi will also produce cosine t to be 0, but it's okay to look at those. We're only looking at from 0 to 2 pi. All right, the next time sine of t is equal to 0 when t is equal to 0 and pi. And then again, 2 pi times any integer multiple of these will also be 0. But again, we're looking at from 0 to 2 pi. We don't need to go beyond that. So we have, well, 2 more critical points on the boundary. So we have this one to test. That's when t is equal to 0. And this one to test when t is equal to pi. And this was when t is equal to pi over 2. And this was when t is equal to 3 pi over 2. All right. Now, the next equation, we can rearrange. So I'm going to rewrite this by using the Pythagorean's identity. So we know this is 3 cosine of t plus 2. Sine squared t can be written as 1 minus cosine squared of t equals to 0. And then little distribution here, you'll have -3 cosine of t plus 2 minus 2 cosine squared of t equal to 0. Let's rearrange and multiply by a -1. So you'll have 2 cosine squared of t plus 3 cosine of t minus 2 equals to 0. All right, now it looks like a quadratic, so we need to do a little substitution. Let me introduce a variable. Let w be equal to cosine of t. So I have 2w squared plus w minus 2 equals to 0. Now it looks like a quadratic that we can easily factor. This is 2w and w. So we need to find what are the factors. So perhaps +2 and -1 should do. All right, so these are the factors. And now I can set each factor to 0. 2w minus 1 equals 0. Then we have w plus 2 equals to 0. But what is w? Well, w was just a substitution I made along the way. That's cosine t. And I'll replace it back. We got 2 cosine t minus 1 equals to 0. And then here you have cosine t plus 2 equal to 0. Here we have cosine t is equal to add 1 divided by 2, 1/2. So we need to find what are the t values. So its cosine is positive in 2 different places, first quadrant and fourth quadrant. So we need this angle, that's pi over 3. And then we also need this angle. Remember, we're only looking at from 0 to 2 pi, so don't go beyond that. The next angle should be 2 pi minus pi over 3. That's 5 pi over 3. All right, so there are 2 more critical points we got. Let's put them on our picture. So we have one right here to test. That is when t is pi over 3. Then we also have another one right here. Let's just say here, not drawn to scale. This is t is equal to 5 pi over 3. All right, so we got 6 critical points along the boundary to test. All right, looks good. Continuing on. And this equation, this is cosine t equals -2. Well, this gives us no solution, so we can ignore that. All right, so now let's go ahead and test our function along the boundary. So I'm going to go ahead and just copy this down. That way we don't have to keep sliding up and down. All right, so let's check. Let's check each of these boundary points. So we know that when t is equal to 0, what is the point here? Well, we know the x coordinate when t is equal to 0, it's going to be 1, and y is 0. So again, how I'm getting that? Well, I know x is equal to cosine t, y is equal to sine of t, because that's how we parameterize the curve along the boundary. And for this one, cosine of pi over 3, we know that's going to be 1/2. Sine of pi over 3, that's square root of 3 over 2. And at this point, cosine of pi over 2, that's 0. Sine is 1. And at pi, we have x is -1, y is 0. At 3 pi over 2, the coordinates are y, x is 0, y is -1. And at 5 pi over 3, we have, so it's similar to this one, x is same, but the y is negative. So we'll have 1/2 negative square root of 3 over 2. So those are the points we're going to plug in into our original function and see what we obtain. So the original function is right here. Let's put everything down. And also don't forget 0, 0. That was the first thing we had earlier. So here's the original function. Let's plug them in. So first point I'm going to plug in is this one, 1, 0. So f of 1, 0, that's 2 times 1 cubed plus 0. That will be 2. The next point we're going to do is 1/2 and square root of 3 over 2. That's 2 times 1/2 cubed plus square root of 3 over 2 to the 4th power. Okay, so this gives us about 1 over 4 plus this is about 9 over 16, which will give us about 13 over 16. All right, so let's hold on to that. So this is the function value at these 2 points, and at 1, 0, we have 2. Okay. All right, we have a couple more to go through. Then we're going to find f at, so we did this one, now let's find that one. At 0, 1, that's 2 times 0 cubed plus 1/4. That would be 1. Okay. All right, let's hold on to that as well. Then we're going to go into this one right here. We have f evaluated at -1, 0. 2 times -1 cubed plus 0. That would be -2. Okay. And then the next one we're going to go to is this one right here. Oh, okay. So we have to evaluate f at the point 0, -1. That's 2 times 0 cubed plus -1 to the 4th. That's going to give us 1 again. Okay. All right, we're almost there. The last point we need to check is this one. And that's going to give you exact same as this one right here, because when you plug in x equals 1/2, this is a negative square root of 3 over 2, but because you're doing the 4th power, it'll still give you 9 over 16, and this will be the same thing. So I know this is exactly the same as f evaluated at 1/2 negative square root of 3 over 2. Okay, so these two gives us the same value. Okay, so the next thing I'm going to do is now compare these values. So this is kind of like our step number 3. There's one more point we need to pick up early on. That was our critical point right here. So at 0, 0, the origin, we got the value 0, 0. Okay, so let's put that in here. So along the boundaries we tested, and then the critical number gave us 0, 0. Let's see which one is the largest. So it looks like the largest one we have is this one right here. So this will be your absolute max. And the lowest is this one right here, -2. So that would be our absolute minimum. So this is our absolute maximum, and the value is 2, and this will be your absolute minimum. All right, I hope this helped you understand this question. There's another question I have done. I'll link the link in the description box for you to check it out. All right, this is it. I'll see you next time. Take care, everyone.